Hello everyone, and welcome to the first episode of Geoduck, an approximately weekly science communication series focusing on topics related to geology, climate, paleontology, and micropaleontology. In today's episode, we're going to be taking a look at the extraordinary new documentary series Prehistoric Planet and evaluating its scientific accuracy. We're going to be looking at the creatures presented, the environments reconstructed, and the species of plants they present, as well as the speculative behaviours in the animals. I am a paleoclimatologist myself, with an extensive background in paleo-environmental research, so I may get very critical at times, but any criticism I make is made entirely out of love for this series and for this genre of reconstructing past ecosystems and showing them to the world as they were as best as we can. So I want to make it clear from the get-go, before I start, that I adore this series and the immense strides that it takes to presenting dinosaurs, pterosaurs, and marine reptiles as realistic animals with realistic behaviours, and the huge pains that were taken to make the reconstructions as accurate as possible to the accepted science right now, with a good healthy deal of speculation. According to the introduction, the entire series takes place during the lattermost part of the Maastrichtian stage of the Late Cretaceous period, approximately 66 million years ago. Some of the creatures shown are from the early or later parts of this stage, and some are from the preceding Campanian stage, but I think it's fair to say that a large number of these animals may well have lived up to the Cretaceous-Paleogene boundary, but there is one instance where the precision of this timing might be a teensy bit important, which I'll bring up once we get to it. Anyway, now that the introduction is over with, let's get on to some reviewing. The first episode, titled Coasts, begins with a beautifully reconstructed Tyrannosaurus rex, affectionately named Hank by the online fan community, swimming with his chicks to an offshore island in the southern Western Interior Seaway. The Western Interior Seaway was an inland sea that effectively split North America into two land masses, Appalachia and Laramidia, with Laramidia being in the west and where Tyrannosaurus remains unknown from. The initial previews claimed that this scene took place in the Tethys Sea, which was a large former ocean, the last remnants of which currently make up the Mediterranean. According to lead scientific consultant of the series, Dr. Darren Naish, the decision to refer to the sea as the Tethys was made because ocean currents from the Tethys were effectively continuing their circulation into the North Atlantic, making this part of the sea a part of the so-called Tethys domain. As someone who has worked on the micropaleontology of Paleocene material from the North Atlantic, though I will admit I have not worked on Cretaceous material, I have never heard anyone in my field refer to the North Atlantic as part of the Tethys among the paleoceanographers that I know, and so I'm glad that this reference was cut from the final episode. I'm especially glad because whilst it may have been the case a little earlier in the Cretaceous to refer to the southern Western Interior Seaway as a part of the Tethys domain, especially when it cut through all or most of North America, during the Maastrichtian stage, this seaway was dwindling, and the southern parts of Laramidia and Appalachia had reconnected, as shown in these 2014 reconstructions by Professor Ron Blakey. Therefore, it's incorrect to refer to this as the Tethys Sea, as the initial previews did. Anyway, the notion of Tyrannosaurus swimming may seem strange, but a number of theropod swimming trackways have been uncovered from the Cretaceous of both Spain and China, where we can clearly see that 3 long toe prints have scraped the underlying sediment. As David Attenborough says, Tyrannosaurus would likely have been an excellent swimmer due to its light bones and powerful limbs, with proportionally large feet. The bone density of T-Rex is distinctly lower than that of dinosaurs often hypothesized to be subaqueous foragers, such as Spinosaurus and Baryonyx, as shown in this plot by Matteo Fabri et al., and it's probable that Hank and his kids wouldn't have been able to swim below the water without floating back up to the surface. As Hank and his kids swim towards the island, they are pursued by an unidentified mosasaur, which according to the narration weighs over 15 tons. I'll assume that this represents Mosasaurus hoffmanni, a frankly enormous predator, capable of reaching lengths of up to 17 meters. The 15-ton mass estimate seems to be roughly within the range of what I've seen suggested by paleontologists online, though I haven't been able to find a specific source for this weight in an academic paper. The mosasaur here is presented with a tail fluke. When I first saw this, I was quite curious, as prior depictions of mosasaurs in media, such as in Primeval and Jurassic World and Sea Monsters, have typically depicted it with a flat paddle-like tail not too dissimilar from that of the monitor lizards that mosasaurs are known to be closely related to. However, a 2013 paper by Johan Lindgren et al. Described a new mosasaur specimen from Jordan which displayed excellent soft tissue preservation. This incredible new specimen revealed not only well-developed flippers, but a lobed fin shape in a convergently similar manner to the tail fins of sharks. The inclusion of this feature is therefore an excellent case of updating reconstructions based on more recent evidence, in a massive win for the series. You may have assumed or heard that the giant 2-ton leatherback-like turtles we see on the island belong to the genus Archelon, a 5-meter-long giant from the northern western interior seaway. But this interpretation is incorrect, as Archelon went extinct around 8 million years before the setting of this episode. They do, however, appear to still be members of the Protostegidae family, the group of marine turtles which includes Archelon. These were the first group of turtles known to be fully marine in the fossil record, and first appear in either the Barremian or Aptian stage of the Cretaceous period, somewhere around 120 million years ago, and they died out along with dinosaurs at the end of the Cretaceous. It's been a matter of debate whether or not the Protostegids are a part of the same lineage as the modern sea turtles, or form a separate lineage of turtles which independently took to the ocean from the ancestors of modern turtles. Currently, phylogenetic work by Cadena and Parkham in 2015 indicates that they are most closely related to leatherback turtles, though they noted that extreme convergent evolution might be getting in the way of their phylogenetics. Since we don't know what type of protostegid these are, I won't try to review their accuracy, though it is nice that they look a lot like leatherback turtles, since phylogenetics suggests that that's probably what they were closely related to. One possible criticism I have towards the design in this sequence relates to the T-Rex. Not the adult, which is possibly the most flawless reconstruction I've ever seen. I particularly love how beefy his belly looks to make room for all of those gastralia. But the juveniles are where I have a slight issue. Before I criticize the reconstruction, I want to point out that it's great that they were given feathers. Tyrannosaurus is a Sauropods, which are a group of dinosaurs that we can confidently say were ancestrally feathered on the base of the fossil record. The early Cretaceous Tyrannosauroid Eutyrannus, which lived in a colder climate than T-Rex, is known from fossils to have been covered in a coat of feathers, but despite skin impressions, there's currently no actual evidence for feathers on T-Rex itself. However, a large part of why this is thought to be is that the larger an animal gets, the lower its surface area to volume ratio, and thus the less easily it loses heat to its surroundings. Think about how little fur there is on large mammals today, like elephants and rhinoceroses, when compared to smaller ones like antelopes from the same habitats. So the idea of T-Rex having a coat of feathers when young and losing them as it ages makes total sense. I particularly love how the patterning of the downy feathers resembles the patterning of the chicks of emus, which is a nice touch. Anyway, on to the one critique that I mentioned I had earlier. I feel like the arms of the Rex chicks are a little too short. For a long time, juvenile Tyrannosaurus specimens were controversially considered to represent their own species and genus due to their wildly different proportions from adults, that being the infamous Nanotyrannus lancensis. While there is still some degree of controversy about this, and I will admit that I used to think Nanotyrannus was valid, the vast majority of research now suggests that they are the same species. And one of the key features used to defend Nanotyrannus as distinct from T-Rex were its much longer arms than are even observed in some adult specimens, indicating that their arms grew rapidly to their full size when the animals were young. The more narrow snout in this juvenile, however, proportionally when compared with the adults, is completely accurate. When old Hanky Boy bites into the dead turtle, Attenborough tells the audience that T-Rex has the most powerful jaws in nature and a bite force of over 5 tons. Musculoskeletal modeling by Bates and Forkingham in 2012 suggests that the animal had a maximum sustained bite force of 57,000 newtons, which is around 5.8 tons of force. So it was actually could potentially have been closer to 6 tons, which is really freaking epic. Anyway. Next, we skip to a coastal pterosaur colony, and once again, I absolutely want to praise the accuracy in all of these designs. Unlike in a lot of other paleomedia, all of the pterosaurs here are covered in hairs known as pycnofibers, which recent work suggests share a common ancestor with feathers. Since pterosaurs are closely related to dinosaurs, it would make sense that feathers or an ancestral quill-like structure had evolved in an ancestral archosaur close to these groups before their ancestors diverged. The sequence appears to be set in the Uled-Abaddon Basin on the basis of the appearance of Tetradraco, Alcyone, Barbaridactylus, and Phosphatodraco. All of these pterosaurs, alongside the species Simhergia and Aramborgiana, which are probably also visible here but go unnamed, since David says that there are 7 species present in this colony. Tetradraco is thought to be a close relative of the iconic Pteranodon, and almost all of this reconstruction is based on that assumption, since we only have a holotype humerus and some extra limb bones to go on. The entire head is speculative. As a pterannodontid, I appreciate that there are no teeth in Tetradraco's bills. Several other documentaries, including ones made by the BBC, somehow made the mistake of including teeth and forgetting that Pteranodon is sexually dimorphic. Note that you can see both crested and crestless individuals on the beach. The Uled-Abaddon Basin is actually a very important fossil locality for pterosaurs, as prior to its finding, it was thought that the only group of pterosaurs left at the end of the Cretaceous were the Azhdarchids, the big death stalks, which include Phosphatodraco, as well as the iconic Quetzalcoatlus and Hatzegopteryx, among many others. Basically, all of the other long-necked creepy ones, which I love. However, when pterosaurs from this site were described by Longrich et al., it became apparent that at least 2 other families were still around and had several extant species in the late Maastrichtian. According to Longrich et al. 2018, it seems that pterosaurs were probably actually doing fine at the end of the Cretaceous, rather than being completely outcompeted by birds, as was long thought, and that the apparent disappearance of non-Azhdarchids elsewhere is probably the result of a poor fossil record, rather than of most other pterosaur groups going extinct before the Cretaceous-Paleogene boundary, which is great news for those of us who love and adore pterosaurs. Which frankly should be everyone, because pterosaurs are wonderful. I also love that we get a reference to the leathery nature of pterosaur eggs, and to the notion that pterosaurs didn't care for their young. This has been somewhat contentious over the years as to whether or not they did, and may well have varied from species to species. David Unwin and Charles Denning in 2019 shows that young pterosaurs were capable of flight prior to hatching, so wouldn't need the kind of parental care that birds give to their chicks before they develop the ability to fly. I also find it realistic how different species appear to have different nesting strategies to avoid predation and avoid competing for space. This is very similar to what we see in modern seabird colonies, and also consistent with the idea that, unlike modern birds, pterosaurs might not have cared for their chicks. In short, this entire sequence is top-tier amazing. We then watch the hatching of a number of Alcyone on a sea stack, who have to fly out to the safety of a nearby forest whilst evading some predatory Barbaridactylus. I find it interesting how all of the Alcyone are hesitant to fly off until one does. It reminds me a lot of footage that I've seen of wildebeest being unwilling to cross crocodile-rich waters and piling up on one side of the river until eventually one crosses and then they all do. Both the Alcyone and Barbaridactylus belong to the family Nyctosauridae. While the next episode's Science Explainer film indicates that we know Barbaridactylus had the enormous crest it's reconstructed with here, unfortunately we actually don't know what kind of crest Barbaridactylus would have had. That said, the very large branched structure we see here is clearly inspired by the dramatic crest found on the closely related species Nyctosaurus, which is a pretty good decision in my opinion. I also need to compliment the frankly horrifying cinematography in this sequence. The direction is phenomenal. Our next sequence follows Torangosaurus, a species of plesiosaur known from New Zealand. I find it interesting how they parallel the relationships between the mother and calf with the nurturing relationship that modern cetaceans have with their calves. And this is something that I will discuss a bit later when I talk about the giving birth scene. The fact that the mother and calf pick up stones to ingest is also well in line with the fossil record, with plesiosaurs being known to ingest proportionally large gastroliths relative to those used by land animals. Whilst land animals tend to use gastroliths for food processing, it seems that marine reptiles did this as a means of reducing their buoyancy primarily, making themselves heavier so that they can more easily swim down to deeper depths without floating to the surface. A study by Michael Taylor in 1993 found that there was no relationship between the presence or absence of gastroliths in marine reptiles and what kinds of things those marine reptiles were eating, indicating that food wasn't the primary reason, and argued that gastroliths are a more efficient way of reducing buoyancy than producing bigger, thicker bones. You may notice that the plesiosaurs here are shown with a distinctive wedge-shaped tail fin. Most older documentaries and toys, and I will fault my beloved Walking with Dinosaurs here too, showed plesiosaurs without such structures and with generally sort of cone-shaped tails. However, we've actually known about tail flukes or fins in plesiosaurs since soft tissue preservation showing it was observed in the holotype specimen of the plesiosaur Coelosaurus Guilleminimperatus. Coelosaurus Guilleminimperatus by Dames in 1895, though it's uncertain if this fin would have been horizontally or vertically oriented, That said, it's great to see this feature finally get included in a documentary. The entire sequence is spot on in terms of the reconstruction of the animal's appearance and behavior, and it is frankly fantastic. I love that this next sequence references rising sea levels and its impact on marine life and the resultant growth of coral reefs. It's no secret that sea level change during the Cretaceous period was quite erratic, and this led to some very interesting things going on in the world's oceans. Notably, as documented by Shelley Thibodeau in 1993, several genera of benthic foraminifera, a group of single-celled organisms that tell us just about everything we know about past climate change and ocean circulation, with cool pretty little shells, which had been around and living in brackish swamps since the Carboniferous, suddenly appear all together in much deeper water during the Cretaceous, which may be due to flooding of their prior habitats, forcing them to adapt to deeper water to avoid extinction. But that's an irrelevant tangent. You want me to talk about Mosasaurus hoffmanni, and I will, but first, fish. Whilst most of the adorable actinopterygians we see in this section are modern reef fish, some are very special indeed. These distinctive little guys with a spike at the back of their head belong to a group called the Pycnodonts. These guys appear to be based on Scalacurvictis nashii, as drawn here by the incredibly talented Ashley Patch, whom you should follow for all of their incredible paleo art. Scalacurvictis nashii, as you might have guessed, was named after Dr. Darren Naish, the series' lead consultant, so it's a pretty fun species to include here, even if it is about 30 million years too young. That said, the Pycnodonts were a very successful and diverse group of fish that took up a wide variety of niches from the Triassic right up until their extinction in the Eocene, so it's great to see some representation of this group in a documentary, especially when everything else here is from modern groups among the fish we see. It goes without saying how realistic the cleaning station behavior is, since pretty much every living medium to large-sized marine organism uses reef fish for this purpose. And it's particularly likely since, as a lizard, mosasaurs have got to shed their skin. I'm assuming that they're actually feeding real lizard or snake skin to these shrimps and fish, which is quite cool. At least that's what it looks like they're doing. Another cool detail, and win for accuracy, is the inclusion of pterygoid teeth, which are a second row of teeth on the inside of the mouth, which would have helped grip on to struggling prey. This is seen in all mosasaurs, and it's thought that many species use the top jaw to hold on to their prey, whilst ratcheting the prey backwards with the lower jaw. That said, these teeth are unusually small in the Hoffmann's mosasaur, and there's a good chance this species didn't actually feed in this way. The dramatic battle that we see between the mosasaurs over territory, with the younger male brutally attacking our peaceful ocean man friend, is also something we see supported in the fossil record, as seen in this fossil of the closely related Mosasaurus missouriensis. Photos from the Royal Tyrrell Museum, violent intraspecific combat was certainly occurring in this group, presumably over either territory or mates. So in terms of accuracy, this is yet another pretty much entirely flawless sequence with realistic behaviors and up-to-date reconstructions. The next sequence, displaying beautiful bioluminescent scaphitid ammonites, is wildly speculative, but absolutely spellbinding. The bioluminescence is similar to what we see in modern firefly squid and lycotoothed squid, but it's controlled and sort of flows through the body almost, in a manner more similar to how we see a more typical squid and cuttlefish communicate using their colours. The idea of mass gatherings of ammonites is also very plausible, given the sheer volume of them that you'll find together in some horizons of the Jurassic coast of the south of England, and in parts of a beach near to where I used to live, which I won't name on here since I don't want tons of people to come and plunder it. Fun fact, since I don't have much to analyse here due to the speculative nature of everything, in my undergrad research project, I found the oldest known specimen of a species of ammonite called Deshaecytes spathii, so ammonites have a very special place in my heart. We then go back to New Zealand, where we see a large group of Torangosaurus swimming together in a pod like a group of cetaceans. One female lags behind the pod due to a pregnancy, and this prompts her to be targeted by a Phytoliths, one of several species of mosasaur known from around New Zealand. The behaviour of Torangosaurus acting as a group to drive the Phytoliths away is also a behaviour that has been documented with dolphins acting together as a group to drive away sharks. The fact that the mother Torangosaurus gives birth to an enormous baby almost half her length is something we have direct fossil evidence for in plesiosaurs, which has been used to infer that plesiosaurs probably had very strong protective familial bonds, having to protect the babies since they only have one offspring at a time, and this requires a huge amount of energy, probably weakening the mothers during the pregnancy as we see in this episode, requiring a degree of group protection. So yeah, that was the first episode of Prehistoric Planet, and I would consider it a near-flawless masterpiece that accurately represented the current state of paleontology for the environment and creatures in it, with a healthy dose of speculation. Now on to Episode 2, Deserts. Deserts begins with a huge group of male Dreadnoughtus, an enormous species of Titanosaur, the same group of sauropods which contained other giants like Argentinosaurus, Patagotitan and Australotitan among others. These were the largest animals ever to walk the earth, and it is great to see sauropod feet reconstructed as looking like sauropod feet, as so often in documentaries they're incorrectly given elephantine feet that exclude their semicircular columnar toe pattern on the front feet and fleshy padded sticky out at the front hind feet. That said, I have seen some uncertainty online about whether or not these feet are accurate, since, as discussed by Sebastian Apagustia in 2005, later titanosaurs appear to have had these thumb spikes either greatly reduced or lost altogether. That said, we don't actually have the front feet of Dreadnoughtus fossilized, so I can't actually say that these are wrong, but unfortunately it looks like there's a good chance that they are in this case. Despite this, what we see here is utterly fantastic. The 40-ton mass estimate is well within line of a 2015 estimate by Carl Bates et al., and the length estimate also appears to be right based on extrapolation from its relatives. These were absurdly huge creatures, and it's amazing that they're here portrayed in combat, since for so long we've tended to only think of sauropods as gentle giants, thanks no doubt to their portrayals in media such as Jurassic Park and The Land Before Time. One interesting feature is the rather abrupt angle change at the spine of the Dreadnoughtus around the base of the tail. This may be in reference to a study by Vidal et al. In 2020, which found that sauropod sacral vertebrae, i.e. the vertebrae at the base of the tail that is fused together, have a distinct wedge shape, which appears to be part of an adaptation towards high browsing. The necks of sauropods are well known to be filled with air-filled hollows. You may have recently seen evidence for a sauropod having a respiratory disease based on these. And it is entirely plausible that weird display structures like the little inflatable balls we see here might well have been associated with them, in a similar way to the large number of birds that exploit neck sacs for display. The notion of sauropods battling each other with their necks has previously been discussed with the apatosaurs by Michael Taylor et al. Back in 2015, because of the extremely thick, exceptionally robust necks of that group compared with their relatives, as envisioned in this epic artwork by the talented John Conway, whom you should absolutely follow. While Dreadnoughtus are titanosaurs, not apatosaurs, they obviously also have extremely robust necks. And all of the behaviours we see on display here are not only plausible, but I would argue are probably more likely to have happened than not to have happened. The next segment opens up in the Gobi Desert and appears to adapt the Nemegt Formation, the Baranguyo Formation, and the Jadocta Formation sequence, which runs from the Campanian to the Maastrichtian and contains many of the most iconic and interesting dinosaurs from the late Cretaceous, some of which appear here alongside some underrated gems. There's actually nothing wrong with them doing this and including Campanian and Maastrichtian dinosaurs together, or supposedly Campanian and Maastrichtian dinosaurs together, because whilst these formations were generally thought to have been a succession of oldest to youngest, from the Jadocta Formation up to the Nemegt Formation, some very recent work by Tomasz Jerzikowicz et al. In 2021 shown that these formations actually passed laterally into one another and were forming at the same time as one another in a dune field, an oasis, and an alluvial plain. The differences in fauna can also be explained by the differences in preservation potential between the sub-environments. So there is no problem whatsoever with showing Velociraptor in this time and place for anyone thinking that the legendary Dromaeosaur is too old to be showing up here. The segment opens on what appears to be an Agamid lizard. This family of lizards are abundant throughout much of the world and have a fossil record stretching back to at least the Cenomanian, and there are many desert-dwelling members of this family today, so that's all good. That said, there haven't been any Agamid fossils found in the Nemegt, Baranguyo, or Jadocta formations yet, but there have been several iguana relatives. It's still very plausible that an Agamid like this would have been found there at around the time though. We quickly start showing Tarbosaurus bataar, here with some speculative minor feathering. Attenborough's line, the equivalent in this desert of T-Rex, is more literal than just how it shares an equivalent top predator niche. Tarbosaurus is a very close relative of T-Rex. So close, in fact, that it has sometimes been argued to actually be a species of Tyrannosaurus, possibly alongside the Chinese species Zhucheng tyrannus. However, some studies like Huram and Sabath in 2003 argued that there are key morphological similarities between Tarbosaurus and another much smaller and narrow-snouted Asian tyrannosaur called Alioramus, and more similarities between T-Rex and another American tyrannosaur, Daspletosaurus, than these two groups have in common with one another, to possibly indicate that Tarbosaurus and T-Rex aren't actually part of the same tyrannosaur lineage, and instead might have developed a lot of similarities as they got larger through convergent evolution. That said, this matter doesn't really seem to be settled, and from what I gather, there are still plenty of supporters of Tyrannosaurus bataar, including Nicolas Cage, who calls his skull a Tyrannosaurus, according to every media outlet. Next, the most staggeringly beautiful and scientifically accurate Velociraptor possibly ever put to screen makes an appearance. Technically, this specimen is based on indeterminate velociraptorine remains, i.e. the remains of what are either Velociraptor or a close relative of Velociraptor from the Nemegt Formation. But following Jerzikowicz et al.'s work, there is no longer any reason to say that this isn't Velociraptor, since it looks like Velociraptor did in fact coexist with all of the other cool dinosaurs we're seeing in this sequence. Anyway, whilst this raptor chases our little Agamid lizard friend, Attenborough says that velociraptors often hunt together. While it is plausible that they may have hunted in groups, even coordinated groups as we see in modern Harris hawks, I feel a need to note that isotopic analysis of Dromaeosaur, that's the group that these raptors are part of, teeth, by J.A. Fredrickson et al. In 2020, showed that at least for the species Deinonychus antiropus. Adults and juveniles seem to have eaten different foods to each other, so the dromaeosaurs wouldn't have been hunting in coordinated packs and sharing the spoils like we see in wolves. We see after the raptor crashes into a Tarbosaurus that several Tarbosaurus individuals are hanging out together. The idea that tyrannosaurs lived in family groups is one that has some support, with the dry island bone beds in Alberta having the remains of 26 of the tyrannosaurid Albertosaurus at all stages of life, which apparently died together and may have lived together as a family group. Next, we see the beautifully reconstructed Mononycus, a very interesting theropod belonging to the Alvarezsauridae family. I initially thought that her extremely owl-like appearance was simply an adorable design choice, but there's actually some solid science behind their decision, and it is fascinating. Barn owls are known for their exceptionally good hearing, and their heart-shaped facial discs collect and direct sound towards the inner ears. In a recent 2021 study by Johann Choinière et al., it was found that the ear bones of the very closely related Alvarezsaurid Shuvia deserti appear to have been just as well adapted to picking up the quietest of sounds as the ears of barn owls, and seem to have undergone considerable convergent evolution. For an animal that appears to have been very reliant on hearing, it's certainly plausible that they would enhance it further using facial discs in much the same way that modern barn owls have. It's also great that we see the animal feeding on termites, since work by Phil Center in 2005 showed that this was the most likely use Mononycus would have had from their claws, since they would have been able to pull and hook as well as scratch dig into nests, but wouldn't have been able to grasp prey or dig burrows with them. Next, the reconstruction of Barsboldia is excellent. The tall neural spines present on the holotype are clearly displayed, giving it an almost sailback appearance. This species was initially thought to be a lambeosaurine, a member of a group of hadrosaurs with large distinctive head crests, but 2011 phylogenetic work by Albert Prieto Marquez found the species to be a basal saurolophine, a group made famous by Ducky from The Land Before Time, based on features of the ilium, and this seems to have stuck, which is why we don't have any ultra-exciting wacky head crests on display here. The next sequence, featuring an oasis watering hole, is frankly the most beautiful scene in the entire series. The Mongolian Titan sauropods that we see here are not named scientifically because they are only known from a single footprint which was recovered from the Nemegt Formation and appears to be around 18% larger than the largest known sauropods from the region. It's cool to think that there's an absolutely enormous sauropod waiting to be found out there. We also get a great cameo from Therizinosaurus here, but I'll save my discussion of that legendary beast for the forest episode. I also love how when Tarbosaurus comes down the dune to the lake for a drink, all of the prey species get out of the way and give it a wide berth, because they know that if it wants to, it's going to have a frickin' buffet here. But at the same time, they're not going to want to leave the lake, because in an environment like this, water is essential. This behavior by the prey species is a lot more realistic than what we see in Jurassic World Camp Cretaceous, wherein at the watering hole, prey species just happily drink right next to large theropods. One thing that seems like a slight omission from this watering hole scene are the various small to medium-sized hornless ceratopsian species, which were apparently abundant in both the Jadocta and Baranguyo formations, most notably Protoceratops and Bagaceratops. This to me feels like a bit of a missed opportunity, given that the episode features Velociraptor, and we have direct evidence of Velociraptor hunting Protoceratops in the form of what might be the coolest fossil ever discovered. That said, I totally get that it is impossible to show everything, and that for most of the time that this documentary was being made, the Jerzikowicz et al. Study wasn't out yet to even indicate that Protoceratops wasn't extinct around the time as these other animals were alive. Anyway, our next sequence returns to following Barbaridactylus, and our much memed-on so-called femboy Barbaridactylus, who lacks a male head crest, which allows him to sneakily mate with females without being attacked by the defending male who rules the roost. This sneaky male physiology and behavior is observed in a large number of species, perhaps most famously cuttlefish, but also a large number of horned mammals and lizards, as they discuss in the following program. I believe that while very speculative, the sheer number of times this thing occurs in the modern environment makes it highly likely that this would have occurred plenty of times in sexually dimorphic archosaurs as well. Our next sequence is one I probably didn't have enough time to do enough research on, so feel free to let me know if I am missing anything in my research here. But this takes place in a gypsum sand desert in South America. David Attenborough makes a bit of a flub at the opening line here when he said that these dunes were not made out of sand but of gypsum, since, to a sedimentologist, sand actually refers to the size of mineral particles, not the mineral that they are made of. In this case, this is sand that is made up of gypsum. The Sosanosaurus we see here are described from the, and please, I apologize for my pronunciation, and lots of my pronunciations have been terrible in this, the Lago Colhuahuapi Formation in Patagonia, which, so far as I can tell, was not an unbearably dry gypsum desert. In fact, it seems to have been a quite wet floodplain, and even had a cool crocodiliform, so I don't really know what's going on here in terms of paleo environment. However, if I were to hazard a guess, I would say that this sequence is likely to be inspired by an assortment of dinosaur tracks from Bolivia, where the sedimentology indicates that a gypsum desert was present and is now pseudomorphed, i.e. meaning that the shape of where gypsum crystals once were but have since dissolved by water is now filled up by other minerals. It seems that dinosaurs did migrate through this gypsum desert based on the presence of tracks in order to get to various wetlands, and it looks like there were very extensive multi-species migrations through this environment. To be honest, I haven't yet had a chance to thoroughly read this paper, though the fact that we know that there were gypsum deserts in South America at the time that this hadrosaur was around makes this whole section plausible, even though we aren't getting the diverse mega-migrations that C.A. Mayer and co. describe from the region. So, in summation, this second episode is truly extraordinary. So far as I can tell, aside from maybe the sauropod feat, there were no real errors at all. The reconstructions and behaviors were once again top-notch, and I massively commend everyone involved in making this episode. Thus far, these first two episodes get a solid 10 out of 10 for accuracy. Now I'm going to talk about episode 3, Freshwater. This is the final episode that I'll be talking about in this part 1 video, as I just don't have time to get an entire review of the whole series out by Sunday as I initially promised. Part 2 will be coming out next week. Anyway, episode 3 begins with a staggering return to the Gobi Desert, where along the bank of a river we see a large group of unidentified pterosaurs flying to a colony on the cliffside. Although the pterosaurs go unnamed throughout the segment, Darren Naish has confirmed that they are all juvenile as darkids, which were pretty much globally present. The stunningly reconstructed Velociraptors then hunt them in a manner clearly inspired by the cliffside hunts of snow leopards, whilst also highlighting a loose social structure amongst the raptors. I like how it's pointed out how valuable their wings and tails are in scaling these environments. The raptors also appear to have been given sexual dimorphism, with the two males having orange on their breasts. Given the close relationship between dromaeosaurs in birds, in which we know males usually have more vibrant coloration, I think this is a really nice touch. Honestly, this is probably the best dromaeosaur sequence ever put to television, and I don't really have much else to say about that. We then skip to North America, where we are initially shown a Swiss cheese plant in the genus Monstera. The Araceae family, of which Monstera are a part, had already evolved in the early Cretaceous, so having something that looks like this probably isn't all that unreasonable at all. I must confess, however, that this North American sequence actually disappointed me a great deal. For an episode focused on freshwater ecosystems, we don't actually get to see the organisms of North America's freshwater ecosystem at all. Instead, we have a sequence where we catch up on our old buddy Hank as he chows down on a Triceratops he's taken down, unfortunately being injured himself quite badly. The Triceratops only has a very small nose horn, indicating that it belongs to the earlier species Triceratops horridus, instead of the probably more iconic, later species Triceratops porosus. This indicates that we are a teensy bit earlier than the 66 million years ago that David Attenborough's initial narration told us we are. T-Rex then goes to the river, and we get one of many, many missed opportunities in this episode. The Hells Creek Formation hosts a huge variety of freshwater life, including an assortment of fish, turtles, the narrow-snouted gharial relative Thoracosaurus, the alligator relative Brachychampsa, the basal Eusuchian Borealisuchus, and the fascinating Champsosaurus, which was a member of the Carista Derens. The Carista Derens were a very diverse group of semi-aquatic reptiles, which included several forms like Champsosaurus, which convergently evolved a similar niche to crocodiles despite not being closely related at all. The Carista Derens lived all the way from the Jurassic or maybe Triassic until as recently as 11 million years ago. I find it very odd that in a formation like Hells Creek with so much freshwater diversity, once Hank goes into the water, we then get a mating ritual with a female T-Rex instead of showing off the ecosystem that we're promised in the episode's title. That said, I will praise the sequence for showing a nuzzling behaviour between the T-Rexes. It's thought that nuzzling may well have been important to tyrannosaurs and other theropods, as their snouts were covered in nerve openings called foramina, which would have allowed hundreds of branches of the trigeminal nerve to reach the surface of the snout, making it extremely sensitive to touch. Because of these behaviours, I want to make it clear that I do like this sequence, but it has so little relationship to the freshwater environment that it probably should have been in the forests episode instead. That said, there's nothing scientifically wrong with it. Anyway, we next go back to the Gobi Desert, this time visiting a lush lowland wetland. And once again, we are returning to the Nemegt Formation that we visited in the Deserts episode. Before we take a look at the start of this animal that we're going to be showcasing, we are treated to a great view of some reed grass. There are a lot of grasses featured throughout this particular episode in the background of scenes, and watching this for me, that set off alarm bells. It was long thought that grasses didn't appear until after the extinction of the dinosaurs because of a lack of any fossil evidence for them. You may have seen the Making of Walking with Dinosaurs, where they specifically avoided anywhere where they could find grass and went to great pains in their location selections to avoid grass. However, in 2005, Vananda Prasad et al. Published the findings of phytoliths, that is, the silica spines that make a lot of grasses so sharp and so rough. You can really feel them when you rub your fingers down a grass leaf. And they found the spines of 5 different species of grass in the fossilized poo of Titanosaurian sauropods from India from around 66 to 67 million years ago. So, right towards the end of the Cretaceous, there were already 5 species of grass, at least in just one area. So, we know that grasses were indeed around at the time this episode is set, and were just starting to diversify. The grasses that we see in the Dinochirus' wetland are a reed grass, which could belong to the genus Arundo, the genus Phragmites, or the genus Neyraudia, though I'm not aware of any fossil record indicating that these kinds of giant reed grasses were present at the time of the end of the Cretaceous period. There is perhaps some logic in including grasses with this particular body plan. You see, despite looking almost identical to one another, to the extent that you really need to get your eye in to tell which one your wetland reed actually belongs to, especially if you're in an area you're unfamiliar with, the genera Phragmites, Arundo, and Neyraudia are not actually very closely related, and look very similar to one another as a result of convergent evolution. So it makes sense that they would pick a wetland dominated by plants that have a body plan which keeps evolving over and over again, since it makes sense that it may have convergently evolved in similar wetland monocots in the past. We then get to see the bizarre, the extraordinary, the beautiful Dinochirus. Dinochirus is the largest known member of the ornithomimosaurs, the same group which includes the famous from Jurassic Park Gallimimus and the famous from The Land Before Time 2 Struthiomimus. For a really long time, we didn't really have much of a concrete idea of what Dinochirus was, since when it was first discovered in 1965, all that were found were its arms and some extra bones to do with the shoulder girdle and stuff. And the arms had massive hands, which led to it being called Dinochirus, which literally means terrible hand. It wasn't until the 2010s, when more material was uncovered and or made available to science, that the truly bizarre nature of this beast became known. The reconstruction here is absolutely flawless, as is its association with the wetland, for reasons I'll get into in a bit. We know that smaller ornithomimosaurs had shaggy, ostrich-like feathery coats, so I'm all good with this extrapolation. Despite the fact that our adorable ball of perfection is here only seen eating water plants, we know that they actually appear to have had an omnivorous diet, with fish scales and vertebrae being found inside the stomach of their remains. Overall, however, this cool sequence of Dinochirus eating and scratching some itches and pooping, it's really accurate to what we know of the animal. Though I feel that David Attenborough's claim at the end that it almost entirely fed on vegetation rather undersells the animal's true omnivory. Still, this scene was a great addition to the episode, and much appreciated. Now, sadly, we get to the point in the episode where I stopped liking it as much. We switch to a swamp in southern Africa. According to zoologist Tom Parker, the vegetation of this sequence is much more appropriate for North America during the Maastrichtian than it is for Southern Africa, to the extent that there were some people wondering on Twitter whether or not this was a narration flub, which is further confounded by the inexplicable appearance of Quetzalcoatlus, which is from North America, not the fossil record of Southern Africa. According to Darren Naish, this was done with the intention of highlighting that it's considered very plausible that giant Azhdarchids like Quetzalcoatlus may have undergone vast cross-oceanic flights. However, as all fossils of the genus have only been found in North America, I consider this a little odd, because just because an animal is large and flies and can fly long distances doesn't necessarily mean it crosses continents. I mean, take the Andean condor or the Philippine eagle or basically any other large, primarily terrestrial bird, and they don't do this. Many of the birds which undergo large cross-oceanic migrations are really quite small, like Arctic terns or bar-tailed godwits, the latter of which have been documented flying for 7,500 miles non-stop. This is confounded further by the fact that the narration doesn't state that they're mainly known from America or that this female is migrating here from America as part of an annual migration. So it doesn't really highlight the intended purpose of showing this creature undergoing a migration. David tells us that our female's wings are over 30 feet across. This indicates that she belongs to the larger of the two known species in the genus, Quetzalcoatlus northropi, and not the recently named, much smaller, Quetzalcoatlus lawsoni, which on the diagram I'm showing here is called Quetzalcoatlus sp, as it was only fully described last year. When she lands, she walks with a narrow quadrupedal posture proposed by Mark Whitten and Darren Naish in 2008. It's good, in my opinion, that Attenborough highlights the Quetzalcoatlus's competence on the ground, as a ground hornbill or stork-like behaviour has been found by Whitten and Naish to be their most likely lifestyle. There was some suggestion by some researchers a few years ago that the giant Azhdarchid pterosaurs might have been flightless, with Dr. Donald Henderson of the Royal Tyrrell Museum still holding this view. But if you want a thorough breakdown on why he's wrong about this, and why we are pretty freaking sure they could definitely fly, I'm going to be attaching a brilliant blog post by pterosaur specialist Mark Whitten that gives all of the evidence in support of the fact that they could indeed fly. And maybe I'll even make an episode on that one day. According to Naish, we know from fossils that pterosaurs could produce 2 eggs at once, one from each ovary, and that clutch size may have been tiny, i.e. 2, or large, i.e. 12. The makers of the show opted for a larger clutch of around 12, since the total clutch mass of this size appeared right for an animal this large, as Quetzalcoatlus was around 220 kilograms. Overall, again, this segment is excellent, also highlighting some brutal behaviors from a competitive female who destroys our mother's nest. That said, a friend of mine did message me after this episode to complain that she thought there were too many pterosaurs. I'm not complaining. I freaking love pterosaurs. That said, this is once again another sequence about the episode which was supposed to be about freshwater ecosystems, sadly not really focusing on the freshwater ecosystem. The next segment, however, is where the episode, in my opinion, starts to lose points for both accuracy and quality. The narration talks about the river flowing downstream and its effects on the landscape. The implication is that we are in a downstream, higher energy part of the same river system as the prior swamp segment. The narration does not at any point indicate that we have moved out of mainland Africa. Keep that in mind as it's important. We then see some crabs in a low-energy sandbank, with these crabs being members of the superfamily Portunoidea, which was also abundant in the Cretaceous and still is today. But then something weird happens. Mononycus shows up out of nowhere and starts eating the crabs. Mononycus, which only lived in Madagascar, and if the narration is to be believed, has apparently been teleported to mainland Africa. Okay. The teeth of this reconstruction appear to point directly up and or down when the mouth is open, which doesn't quite seem to be correct for the animal's very bizarre dentition. That said, it is correct that the teeth should be covered in lips, not making them as bizarre looking as most reconstructions when the mouth is closed, like we see here. Here the Mononycus and her tiny 3 young are feeding on the riverbank, with the mother feeding her chicks the crabs she's been catching. One youngster attempts to chase a crab adventurously, but is suddenly grabbed and killed by the giant frog Beelzebufo, which is also only found in Madagascar. Why these Madagascan animals are being shown when, according to the narration, we are theoretically still in southern mainland Africa, I did not understand. Darren would later confirm via Twitter that this sequence did in fact take place in Madagascar, but since the narration says otherwise, I think we can consider this a mistake on the part of the script writer and not on behalf of the scientists. This particular segment seems to have rubbed quite a lot of people on Paleo Twitter the wrong way, not just because of the misleading narration which implies it's taking place in continental Africa, but because of the sheer number of unusual and unique species that lived around freshwater habitats in Madagascar, which were missing. Since crocodilomorphs were the top predators in most Maastrichtian freshwater ecosystems, their complete and utter exclusion from this entire episode is actually quite bizarre, but especially in Madagascar, where we have the adorable herbivorous so-called armadillo croc Simosuchus, which would have been perfectly happy living in this habitat and sequence, which feels like a huge missed opportunity, as well as the impressive wide-jawed Mahajangasuchus not showing up. According to the narration, we continue to follow this same river to its mouth. But we'll get to that pesky narration later. Note that the narration explicitly says the river at the start, implying we're talking about the same river. Here we see a group of unidentified elasmosaurs swimming into the estuary among the mangroves, around the area where sea and fresh waters mix, attracted by the great schools of fish, which were themselves attracted by the food brought down by the rivers. Honestly, this sequence is fantastic, and there is a lot of precedent for plesiosaurs entering brackish and freshwater estuaries and river environments from the fossil record. For example, this has been observed in the freshwater to brackish lagoon of the Vectis Formation of the Isle of Wight, as described by Benson et al. In 2012. And there are also supposed Leptoclidus specimens known from the freshwater habitat of the Baharia Formation in Egypt. Tingao et al. In 2019 also reported plesiosaur remains from a fully freshwater environment in the Middle Jurassic of China, and the tooth of a pliosaur, a short-necked group of plesiosaurs made famous by mega-resized Liopleurodon of Walking with Dinosaurs fame, was found in inland river sediments from the mid-Cretaceous of Australia. So it's clear that these guys could and did enter these freshwater habitats, and that some plesiosaur species may have even primarily lived in freshwater rivers and lakes, much like modern river dolphins. Despite the narration implying that we are in the same river system as the Madagascar sequence, Darren Naish clarified all of the confusion and revealed over Twitter in his thread on the episode that this sequence was actually set in South America, and that the Azdarchids we see here were shown to highlight how globally present and successful this incredible group of pterosaurs were. This actually makes it very disappointing that the narration never tells us that we've moved from country to country for the entire second half of the episode. Rather, it undermines the scientific team's good intentions by implying that we're following one river. As a result of this, I mistakenly thought that the Azdarchid we see in this sequence was the same Quetzalcoatlus mother we had seen earlier on. So overall, this episode was one that really did not live up to the standards of those that came before, and sadly much of that was because of the narration, not the science, though it was particularly jarring that we did not see so much of the incredible and bizarre biodiversity of the freshwater ecosystems in the Maastrichtian, with the absence of crocodilomorphs being very jarring, since it's pretty much impossible to find a fossil-bearing rock formation in the Cretaceous without several crocodiliform species, often with incredibly diverse forms and ecologies far beyond a lot of what we see today. This was made even worse by the fact that the narration made it seem like the Madagascan wildlife was living in mainland southern Africa, and that the final sequence was too. In my opinion, this episode should have mainly focused on the fascinating diversity of late Cretaceous freshwater fishes, aquatic reptiles, crocodiliforms, and the weird dinosaurs like Dinochirus. Instead, we got two excellent scenes featuring Velociraptor and T-Rex, which felt like they were originally intended to be a part of the desert and forest episodes. And I mean it when I say I liked these sequences a lot. So I'm sorry if this final part seemed more negative. When we get to episodes 4 and 5 in part 2 of this review, the things I say will be much more glowing, as I believe that those two episodes are both utterly fantastic. Part 2 of this review will be out this coming Sunday, if not earlier, and I really hope that you guys enjoy it. I've been passionate about extinct life for as long as I can remember, and this series really brought me back to my childhood watching the Walking With franchise as they aired, and really being sucked in and excited for each new episode, and then obsessing over the details and reading all I could about the species and habitats and environments featured. Hats off to everyone involved, especially the researchers and the special effects artists. Thank you so much, and thank you for everyone for watching. If you like what I'm doing here, this is the first of what I plan to make into a weekly science communication series. I've got videos coming out on the effects of colonialism in paleontology, and a hopefully gloriously clickbaity one coming up about kleptoplasty in foraminifera. If you want to help the channel out, please donate to my Ko-fi account and help fund future videos. So stay tuned for some exciting fun. I've been DJ King, signing off.